All right, last little piece here, Chapter 7. The next thing you mentioned in the chapter is about the concept of to use a patch panel or not use a patch panel, or punch in or not punch in kind of thing. We talked about this almost the first week of class of, at home it's okay to just use patch cables from my desktop into my switch that I have, or my router switch, if you will, on the back of my computer desk. That's fine. That doesn't work in a large commercial building. I really do need something to organize my cabling. And if you think about, the electrical wiring like we have in our house, all the electrical wiring comes from the basement up to outlets around the house, and those are all scattered around the house for easy connecting and disconnecting of my appliances. The same idea is true of patch panel, run all the horizontal wiring out to outlets scattered around the building. I've made it easy for people to plug and unplug their equipment. And now I have a system where I can easily mark and troubleshoot. So the issue really kind of goes away when you actually start thinking in a large building, how would I manage and how would I troubleshoot all this? Yes, patch panels do add expense. They do add an extra point of termination. They do add an extra possible point of failure, if you will. But the idea of having patch panels, it makes troubleshooting easier, it makes organizing things easier, it makes locating connections that would normally be tough much easier. I do have potential for workmanship problems, but it makes all my organizing and everything else easier and troubleshooting easier. So here's my patch panel, and this is really going to be the focus of chapter 8. But there's my patch panel, and just almost think of this as like your circuit breaker box in your basement. The circuit breaker box labeled is just priceless. I can go and flip one switch, turn off outlet so I can work on it. Here I can plug or unplug somebody's data port. Easy peasy lemon squeezy, I'm done. And if I organize everything and label everything, it becomes easy, especially for troubleshooting purposes. So there's just kind of a reminder of organizing all of our cable and patch panels. Patch cable from here down to a switch port. If it's organized, it's easy peasy to connect in and move a connection around, or enable a port or disable a port. It's really easy to do. We'll talk more about copper patch panels in chapter 8. All right, they do mention fiber optic termination again. Remember, with fiber optic, I do have the two ports, one transmit, one receive. I do need to do the crossover connection for the user. That's typically going to be done on the back of the faceplate, if you will. And I do need to label my connections for the user if we are going to have fiber to the desktop. So there's my typical outlet box. There's posts in the corner to carefully coil up the extra fiber optic. There's my faceplate. There's my fiber optic termination. I'm going to do the crossover connection for the user on the back of the port, on the back of the outlet. I will do the crossover for them. That brings us to the marking of our outlets. We mentioned this before. Our TIA 606 standard. I forgot to update that one. Should be ANSI TIA 606 standard. Actually has guidelines on what I should be doing for marking and labeling. I copied these over from our previous PowerPoint. They're saying that my telecommunication spaces should be labeled. Each cabinet rack should be labeled. Labels should be machine printed so they're readable. Patch panels should be labeled. A unique campus identifier should be used. Unique building identifier should be used. All ports on the patch panels should be labeled. Cables terminated patch panels should be labeled. Any interbuilding connections should be labeled. A quick mount outlet should be labeled. I think you're getting the idea. I should be labeling everything with an recognizable scheme, and then I should also be keeping records of this. And now it makes it easy to locate a connection problem somebody's having, trace it through, double check it, or move them. They move their office around, they move over to the other side of the room, and they're like, my port doesn't work. You can say, can you read the faceplate for me? You go to the closet and move the patch cable over and activate that port for them. Easy peasy. We mentioned this before, faceplate idea. Well, the same thing is going to be true for the patch panel. I don't want to have this big, long, ugly, over-labeled system, but I do need a good, organized, labeled system. Oops. I do need a good organized label system, kind of something like this that we talked about. 2 is, building 2 in the company. 2 or 3 tells me the closet. 24 tells me the port, or 2 or 3 tells me the classroom that I'm wiring, and 24 tells me the port and the patch panel. Some sort of organized, kind of consolidated scheme that a label on the cable, I know the closet's going to, I know the room it's going to, I know the patch panel port is going to, that sort of thing. I need an organized system that everybody in the building knows what it's, all my IT people know what it's about. And I do need to keep a chart of this labeled, hanging next to my patch panel in my closet for color coding, or not color coding, for organization and troubleshooting purposes. Absolutely. Workmanship, I need to be installing properly, and we're going to work on that as we do our installations this semester. I can have possible errors here with punching in, so I need to be very careful when I'm punching in, making sure I have the right cable in the right slot. When I'm doing this, I need to make sure I'm routing the cable, no sharp bends, no tight tie wraps. I need to watch my magnetic fields from things like lights and motors and so forth. And then I need to watch my installation and my rules of untwist. If I look at my standard 568C0, they give me a maximum untwist of a half an inch. So I need to strip off just enough insulation to work on it. And when I terminate my wires, I untwist just enough to terminate, or in some cases I actually take the wire pair that's twisted, and I just kind of open it up to slide it over the block. I'll show you that when we terminate, and then punch in. So I do very little untwist to terminate. I need to make sure that twisting stays maintained as far as I can up to there. When I'm punching down, I need to watch the cut side of my punch down tool, and I need to watch that I'm not nicking adjacent wires as I'm doing this. I got to be careful of all of that. As I'm routing my wiring into the rack, they limit my pulling tension at about 25 pound-feet of force. Think about hanging a 25-pound weight on the cabling. That's a pretty good amount of weight. So as I'm routing my cabling, if it's getting hung up, stop. I need to go find where it's getting hung up and carefully route it so I'm not pulling on it. As I pull on it really hard, I'm causing the wire pairs to untwist. That's what's really going on. And then eventually I could snap the cable. As I'm dealing with routing my cabling, I need to worry about my bend radius. According to the standard, my bend radius says I need to have a minimum bend radius of 4 times the diameter of the cable. Well, my cable is roughly in the 1/4 inch diameter, so I need to be in roughly the 1 inch minimum bend radius as I'm dealing with routing my cable. And this is what they're showing you here. As it's going around a corner of something, I need to make sure I'm adhering to this 1 inch bend radius, if you will, or 4 times the cable diameter. And that means this right here. As I'm routing cables in my trays, I need to have a nice round bend in my trays, and then as I'm coming down racks and in the patch panels, nice round bends. Here shows you another, kind of a waterfall in my rack. Nice gentle bends of things, organized and gentle bends. Maintain that bend radius. All right, that's kind of the last bit of things in my telecommunication closet in terminations. Chapter 8 will dig into patch panels in more detail.